Alder Lake. Since the dawn of man, many have sought to swim in the gorgeous waters.
No.
What?
We went over this. We're not doing the lake. It's the name of the 12th.
I understand that, but the processor is named after the lake.
No, we're just talking about the processor.
Alder Lake. The 12th gen Intel processors are built to handle more. Enhanced core and memory overclocking, integrated Intel Wi-Fi 6E support, a new Intel thread director. Today you'll see how we build this PC, which showcases all the technological advantages of the 12th generation Intel processors. So let's dive in, shall we?
It's still not a lake.
I know it's not a lake! You can dive into more than just a lake! All right, everyone, now I'm here with Joe and Jocelyn, two of our builders from the Eniac team. Say hi to the folks at home.
Hello.
And they're gonna take us through this Intel 12th generation build. So, Joe, obviously we know the star of this show is that new Alder Lake CPU, but take us through all the components so we know what's going into this machine.
Well, we're going to be using a GeForce RTX 3080, an iCUE Elite CAPELLIX, that's a AIO all-in-one. One of the stars is the ASUS Z690. One of the first motherboards out there for this specific processor.
So tell me about this case.
Well, this is a Corsair 5000X. Nice big size, nice glass, perfect for this build. So we're also going to be using an 850 watt power supply.
Okay.
Plenty for this processor and this 3080.
I, being an expert but not the star of this, how do we get started? Just so the folks at home know.
So first, as soon as I have the case, I'll remove the glass from the front as well from the back. Having that done, I'll start with my motherboard. After having my motherboard completely done, I'll start with my cooler. From there, I'll continue with my graphics card, and then I'll continue with my power supply as well.
All right, well, I can't wait. Let's get started.
So we are going to go ahead and start off by taking off the glass. It just makes it much more easier when having all the other components done to install them inside.
And I'm here to lend moral support.
So then, as soon as we have this off, we'll go ahead and place this carefully on the table. And then we have, in the back, what's basically a door. So we'll go ahead and remove the tape, just so we can see what we're working with and what cables we have in the back. So then we have basically all our cables that we're going to be working with in the back. Not only are we going to remove the glass, but we also have to remove the door. There we go. And then we have the door removed. Put that to the side as well. So then we'll go ahead and remove the front case as well. And we will gently put it down on the table. And then it gives you a much better view of the case from inside and the back. So then now we're going to go ahead and remove the bracket. As soon as we have this off, it slides right off, as well as the one in the back. So then we'll take this one off as well, and we'll put both of them on the side. So then at this point we have our PC cleared from the front and from the back, so we'll have better access into inserting our cables and managing everything else as well.
Okay, and then we start on the motherboard?
That is correct.
Fantastic.
So this is going to be the motherboard that we are working with. It is the Maximus Z690. It's also known as a gaming motherboard. We'll go ahead and remove the plastic that it has in the front as well as two on the side. And there you go. You have a brand new motherboard. So as soon as we have our motherboard set down, I'll go ahead and remove this. This is the panel where the SSD is going to be inserted into. Now the reason we have to remove this as well is because it also has a plastic underneath. So that definitely has to come off before inserting your SSD.
Definitely.
So some very cool features about this motherboard is that it has a button. So basically what this button does, it opens to where the video card is going to be inserted into, which is amazing. It doesn't close it, unfortunately, but it does open it for you. So then the first thing you'll notice about the motherboard is the socket. So the socket is shaped in a rectangular form. This isn't compared to the LG A1200.
Two previous sockets, which were square.
So first, I'll go ahead and insert the RAM. So today we're working with the DDR5. So it has higher speeds and lower operational voltage, which is really amazing. And it's literally the next generation in memory. So basically when you see your RAMs, you have what's the front of the RAM, and then you also have what's the back. You'll notice the difference because it'll have the name in the front. So it has Vengeance in the front, and then it has like a code configuration in the back. So when you have the code configuration, you know that that's gonna go to the left side, and the part that says Vengeance is gonna go to the right side.
For all your RAM amateurs out there.
Ramateurs.
Yes, ramateurs.
Next, we'll insert our SSD, also known as an M.2.
Yes, the SSD. The SSD, which is right here. I've got it. Just one sec. I'm just grabbing it. And- I found it. There it was.
This little device here takes the place of what originally was a 10-pound spinning platter that used to come in the old days, like 5 megabytes, 200 megabytes. This little device now has 1,000 times more space in it than those old spinning platters. All in a little M.2 configuration.
Were those spinning platters literally 10 pounds?
Yes.
That's insane to me.
Right?
So then as soon as we insert our M.2 into our motherboard, you'll notice that it has a spinning slot, which is very easy for it to be attached. After that, we'll put back the cover, just so it can be more secure. The next step is gonna be our CPU, the 12th gen. So this is the CPU that we are working with. It is the 12th gen. We'll go ahead and lift the socket and then place the CPU inside.
And as I understand, this is not a delicate process at all, right? You can just kind of flick it in there.
Oh, no, no, no. This is a delicate process.
My dear Ben.
You have to be very careful. You have to make sure that it's placed in the right way. As soon as it looks like it is, we'll close the socket and place it back down. So now we're gonna insert our CPU bracket onto the back of our motherboard.
Rack it up.
So it's gonna hold our AIO cooler in place. So now insert the screws.
So the thing I'm learning about building a computer is that a lot of work goes into just getting the motherboard ready. And then once you put that in, it's pretty easy. It's just dominoes after that.
Yeah, I mean, there it is.
So as soon as we have that done, I'll get started with our AIO cooler, all in one.
Oh my God. There's two fans. I found them both.
And voila, we have our cooler. So as soon as we have our cooler set down, we'll screw on our fans.
And when you say all in one, you're talking about all of this in one
Yes.
unit. There's a lot of it here. I'm noticing many screws, two fans, a radiator. This is a pump.
It doesn't start out
And
as all in one. Once you assemble it,
It's all in one.
it's all in one.
At first
Right.
it's just all.
And then it's
all in one.
Yeah.
It's for presenting.
Thank you.
Sir Lancelot here.
That caught me off guard. Okay, so now I will place the CPU pump right into the socket. I'll take off the plastic and I will add just a tiny bit of thermal paste.
About the size of a nickel, what would you say? How much thermal paste?
Probably less, not too much.
I think she's doing some sort of a Pollock.
I see a pyramid.
All right, it's all locked down.
Yes.
Can I help with one thing?
Of
Can I
course.
pull this off?
Go ahead.
That was the best one of the day.
For it?
That was pretty good.
So the next, I will connect the pump. What I usually like to do is to hide all these cables, I'll try to make a loop around the socket.
A custom loop or
Yeah.
just a regular one?
A custom loop.
That's a cooling joke. This is the part of building a computer that stresses me out. Cable management because when I hear cable management, I hear organization. And when I hear organization, my ADHD brain goes, no, 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 no. So I respect the ability to make this look neat and tidy.
So then next, I'll start with the power supply.
Was Power Supply the name of the artist in a Goofy movie? Because maybe love is the reason why, for the first time ever, we're seeing things eye to eye.
So within the power supply, we're going to connect 2 SATAs, we're going to connect 3 PCIEs, our 24-pin, and our 2 CPUs. Okay.
And this is why cable management stresses me out.
All these cables.
That would be it, yeah.
Okay, so then at this point, we are going to get our motherboard and install it into our case.
So now that the motherboard, the RAM, the SSD, and the CPU are all assembled, it's easier to put that one assembly together into the housing rather than put...
So that's called a pre-built, right? We do this in our production line where we try and pre-build everything before it goes into the case.
So at this point, I'm going to install the motherboard into our case.
We should mention at this point that a lot of these components are pre-built into the board, and then all of that assembly is dropped into the case. In our production process, we find that to be more efficient.
All right.
So that is set. There we go. Okay, so then next, I will insert our power supply. Okay. So next, what we're gonna do is we are going to connect our 24-pin and our CPU.
Now, why do they call it a 24-pin?
So then after we have our 24-pin inserted, we are going to go ahead and connect our 2 CPUs.
Okay, so the 2 CPU cords are connected to the 1 CPU that gets power from 2 sources.
Yeah.
That is correct.
What's the next connection that we have to make?
So then next, we are going to connect our Type-C front panel. Now we are going to insert the cable and connect it into our power connection, which is going to be right on top of the USB 3.0, I'm sorry. So then after, we are going to connect our USB 3.2, which as mentioned is going to go right in the bottom of the Type-C front panel, right on the side. So you're able to know if you don't know where it's supposed to be connected. It usually has it on the motherboard.
And then there's a manual also, right?
That is
That
correct.
you can reference to know where all the connections go.
So now we are going to connect our USB, which is going to go through the bottom of the PC, and our power connections as well, such as the reset, the power button, the LEDs.
Need those LEDs.
Definitely. So as soon as we have these in the front, we're going to connect them at the bottom of the motherboard. So first, let's start off with our USB. So as soon as we have the cables through the front, we're going to connect our audio first. Up next, we are going to connect our power switch and our reset switch as well.
And that's what turns the computer on, right?
That is correct. Well, not necessarily. The button turns it on. But so as soon as we have that done, we are going to bring up front our PCIe cables. So we're gonna do this gently just so the grommets won't go out of place.
So the CPU is called Alder Lake. Have you ever been to Alder Lake?
I have not. Have you been to Alder Lake?
As I was asked, I'm the host. I'll ask the questions here.
One part of our QC process is to see how well the cables are managed, and that is cause for rejection if they are not managed properly.
QC, quality control. See, I'm nailing it. Okay, so you check the cables to make sure that they are properly managed, is that?
Yeah, secured. There's an aesthetic value to it. Even if they are secured, they have to be secured in a manner that's pleasing to the eye.
Yeah, it can't just be like stapled down like I would.
Right.
So now that all the connections to the front are made, what's the next step?
We are going to adjust the cooler to the top. So in order to do that, we have to take off this glass.
I didn't even know that moved.
Not just only the glass, but we also have this as well.
Oh, we have like a screen filter.
So then at this point, we are going to lift the cooler, making sure that all of our cables are not tangled up. And we are gonna face it this way. With the rest of these cables, we are going to put them down the PC so they can run through the back. So then at this point, we are going to screw in the cooler to the PC.
Now, how can I position it best? All right, what's the next step?
So next, I am going to insert the video card.
You mean this video card?
A rare and endangered species these days.
So now it's time for the 3080 graphics card.
Oh. So that's it. That's a 3080 graphics card. That's what everyone's losing their mind over. I am too. I would like one. That was short and sweet, and I really liked it. Here's the good one. Yeah. Yep, that's what I live for. Thank you. That's the good stuff. There you are. I'll hand that back to you because I don't trust myself holding it. So we're just opening up 2 PCIe
Yeah, basically.
slots for the card.
There we go.
That looks beautiful.
You installed it nicely.
And that's it? It's in?
It's perfectly
That
secure.
wasn't so hard.
So then as soon as we have that, we are going to cable manage the PCIe cables through the top of the cooler.
So tell me a little bit about the architecture that makes the new Alder Lake so impressive. What's cool about this CPU?
Well, there's 16 cores in the CPU, 8 performance cores and 8 efficiency cores. The performance cores also have hyper-threading. Right? So there's a total of 16 cores with 24 threads.
Okay. And how do those P cores and E cores, the power and efficiency cores, is that what they're called? Or how do they play together? How do they interact?
It'll selectively choose. There's a director built into the core, to the CPU, which will selectively apply through the workload.
So
the architecture will select, depending on your workload, how many cores, how many threads you need.
and which ones and things like that. So just like a director on set, it assigns roles, it divvies up workloads.
Changes frequencies, does all of
Yes,
that.
hot, cold,
Yeah.
it demeans its actors. What's next?
Inserting this one back inside.
This bracket?
This bracket.
That bracket. What a racket. Oh, that was a very kind,
It's a
pity
V-rack.
laugh of
It's a
you. I
V-rack.
appreciate
It's a
you.
So this is a graphics card holder. It's got a magnetic base. It's got 2 little platforms that you can adjust up or down and lock in place. And essentially, you're going to grip the video card between these 2 little platforms and
It just gives
stabilize.
it a little extra support.
Right? That's all it needs
It gets by with a little help from its friend.
from its friend. One of the benefits of this specific graphics card holder is once you get the unit and your GPU no longer needs supporting, then you just put your headphones on there.
Oh, okay, it becomes a headphone rack. So we've got a CPU, a motherboard, a PSU, a GPU, SSD, RAM. What's left?
Well, next we're gonna go ahead and put our fan.
The fan. Ah. Madame.
Thank you. Okay, so then this fan is gonna go on the right side of the PC, having the cables flow through the back of the PC.
This one is pulling air out of the system.
Pulling air out of the system.
Yeah.
Okay.
There we go. So then at this point, we are going to have all of our connections be connected into our controller.
So what exactly is the controller for on the back?
It's for the RGB.
Okay, and that makes the computer run faster.
Actually makes it brighter, change the color, custom color of the fans.
Which all attributes to the performance. I know how RGB works. It
Red,
makes,
green.
when you're overheating, you turn it to blue to cool down. When you need extra performance, you turn it to red to go into Sith mode.
Right, so no.
Understood.
Okay, so now I'm going to connect these SATAs. What I usually like to do is zip tie them separately. That way I don't get them confused. So then just to make it a bit more organized, I like to put them underneath. That way we're not dealing with too many cables at once.
With this amazing cable management. Those cables are managed, man. Look at them. All right, let's get this. Now I'm told that the last step in any build is making sure that it turns on. All right, the moment of truth. Please do the honors. Hey! Hey, thank you so much. Really well done. We're gonna get the glass panels back on, hook this thing up to a monitor, and see what overclocking looks like with this mean machine. Teamwork. So we've got the machine all set up, we've got the keyboard, the mouse, the monitor all hooked up. We are loaded into the BIOS, and we're about to do a little check and see what kind of upgrade we get from overclocking this mean machine. So I understand that this CPU's native speed is about 3.2 gigahertz, correct?
Yes.
What can we expect to see when we've overclocked all 16 cores?
We're expected to see a 5.2.
A 5.2 gigahertz.
Yes, that is correct.
That's a pretty impressive speed boost. That's more than 50%. That's 62.5%. Just came up with that in my head. Definitely wasn't provided that number before we started rolling.
So then I am going to go ahead and change the settings. We're gonna go ahead and do manual. So then the next step would be the Maximus tweak. It's gonna be mode 2.
So this looks like an important screen. What are we looking at here?
So this is pretty much the configuration of the BIOS. So it is demonstrating all the changes we made into the BIOS. So as soon as we're done, we're just gonna go ahead, save changes, and reset.
I didn't touch anything. It's supposed to do that?
No, I'm just kidding. It is.
Start. This?
Yeah. And there you go.
There it is, guys, the bench. Oh, it's a table. So results are in, we've got the test up. Did we hit 5.2?
Definitely, we hit 5.2 on all of our performance cores.
Okay, so there's 8 performance cores, 8 efficiency cores.
That is correct.
I remember stuff. All right, ladies and gentlemen, that's it. That's our build. That's the test, and that's Intel 12th generation CPUs. I want to give a big thank you to Joe and Jocelyn. Thanks for coming here and making me look good by building this beautiful machine in front of me.
Thank you.
Well, I hope you've enjoyed learning about all things Alder Lake. I know I've enjoyed swimming through its performance hybrid architecture, combining P cores and E cores, as well as gentle waves and sandy beaches.
Wait, what? Where did you just come from?
Alder Lake, it's out back.
Out back? Were you swimming in the sewer?